Okay, as we all know, thanks to Fourier, we can write a function f of x as a trig series on the interval from negative pi to pi. And of course, we'll just call this right here to be the Fourier series. And now in this video, let me show you guys what Parseval did. Here we go. We will be looking at the integral from negative pi to pi, and we look at the function, we square that. So I will put down parentheses with f of x inside, and then we square that right here, dx. You guys are going to like this result because we can do a lot of very nice things based on this result. So be sure you watch till the end. Here we go. First of all, of course, we have to assume that this right here does converge to the function on this interval. And when we have that, we can just put this right here for the function. So we have the integral from negative pi to pi, and then we have a parentheses. F of x is just all that. So we will have a0 plus the sum as n goes from 1 to infinity, all this, which is an cosine nx plus bn sine of nx, like this. And then don't forget we square that right here, and then of course we still have to have the dx right here. So that's pretty much the idea. Now we will be looking at this as a binomial because we have the first plus the second thing right here. Square that, of course, we will have the first thing square plus 2 times the first and the second, and then plus the second thing square, right? Everybody in the integral though. So we will break them down into 3 different integrals. First one, we will have the integral from negative pi to pi, this thing square, which is just a0 square. Let's close that, right? So that's the first integral that we have to look at. And yes, to figure out what a0 is, we have to use the integral for that. But don't worry, because this right here will be just a number for our situation, right? And if you want to see how to figure out a0, an, and bn, be sure you guys watch my other video for that. But anyway, continue. Next part, we do 2 times this and that, and that's in the integral. So we add the integral from negative pi to pi, and then 2 times this and that, which is a0, and then the summation. N goes from 1 to infinity, and all this, which is an cosine nx plus bn sine of nx, like this, and then close the integral. Right? So it's like this. Okay, hopefully it's not that bad. Now the third one, we will have to add this thing square in the integral, which is the integral from negative pi to pi. And here's the deal. We have to do this square, and this is a summation. Okay, so do this one carefully. But don't forget, whenever we have something square, we can just put down itself times itself, right? So I will write this down right here first, which is the sum as n goes from 1 to infinity, and then we have an cosine nx plus bn sine of nx, like this in the first summation. And then I will put down another one, the summation in blue, but because I'm putting down another summation, be sure we use a different index. Here I have n, let me use m right here. And don't let the n or the m bother you, they are just the dominant variables, and whenever you are multiplying 2 series or 2 summations, be sure you have different index, right? So this part, we will just be writing this down right here, but change all the n's to m's. So we will have am cosine mx, and then we will have the bm sine of mx, like this. Close that, and don't forget, this guy right here is still in that integral, so we still have to have the dx all the way at the end. Whoa. Okay, cool. Now, let's figure this out. First one, easy. Why? Because, yes, I know a0 is in terms of integral, but it's just a number in our situation. a0 squared is also a number, right? When we integrate a number from negative pi to pi, of course, we just get 2 pi times this number. So the first integral is very nice. It's just 2 pi times a0 squared. Of course, you can do this on your own as well, right? Now for the next one, what we'll do is, because we assume that this right here converge, we are going to interchange the integral and also the summation. And because we have the 2a0, it's just a constant multiple, let me put that down right here first. We add to a0, and let me put down the summation first, which is n goes from 1 to infinity. And then right here, let's look at the integral from negative pi to pi. So I'll put this down now, which is negative pi to pi. And then, of course, we have to write this down here, which is an cosine nx plus bn sine of nx, like this. And then, of course, let's have the dx right here. And before we look at this one, let's finish this. This is actually not that bad at all. Okay, I'll write down some notes right here for you guys. Again, an and bn in our situations, they're just numbers, especially when you are in the x world. Don't worry about them. Right? They're just like a constant multiples. Focus on the integral from negative pi to pi cosine nx. So let me put this down right here for you guys. Note, when we have the integral from negative pi to pi of cosine of, let's just do x first. When you do this, you can do this in your head real quick. You will get positive sine x for the integral, right? And then you put in pi, hey, that's 0. You put in negative pi, hey, that's also 0. So all in all, this will be 0. But guess what? If you have cosine of any constant multiple times x, well, n has to be a whole number, right? And we are having whole number, right? 1, 2, 3, 4, 5, up to infinity, all that. So it's just like, well, n has to be a whole number. Anyway, cosine of nx, integrate that, you will get 1 over n times sine of nx. Putting pi, sine of n pi, when n is an integer, is 0. Putting negative pi, we also get 0, so everybody is 0. Nice. Now, let's look at the other one. Negative pi to pi, we have sine of nx. This also is just 0. Why? Because sine is an odd function. And when you have nx in the sine, that's still an odd function. When you integrate an odd function from negative pi to pi, you get 0. So, in fact, you have two a0 times summation of bunch of zeros. Everybody here, the second term is just 0. So, bye-bye for the second term. Good. Now, for this part, here is the deal. As we can see, we have a summation times another summation. And let me just give you guys an analogy real quick. Remember the times when we do integrals. For example, when you have integral from 1 to infinity of some function, let's say f of x dx, right? This is an improper integral, okay? Times another one, let's say integral from 1 to infinity, but this one, let's say g of y dy, which is another integral. Integral times the integral, in this case, what we can do is we can put the integrals together, integral from 1 to infinity, and then integral from 1 to infinity. And when we put them together, be sure we just multiply the insides together. So we have f of x times g of y. And depending on what you want to do, but in this case, it seems that I'm putting down the dy first and then the dx on the outside, right? So this is doable, right? That's just the idea for this part. So what I'm going to do is, I'll look at this, I'll put down plus, and yes, I will be switching the integration and also the summation, but not yet. I will actually put this and that, well, I'll put down this first, all the way in the front, so the sum as n goes from 1 to infinity, and then I will put down the sum as m goes from 1 to infinity. And we can do that just like really similar to the idea. You can just do this for the double integrals. And then what we'll do is we'll just multiply the insides together. So let's see what happens, right? So here we go. This times that, we have an cosine nx times am and cosine mx. And then we'll just continue, and you see this is like the good old FOIL. This is very nice. This times that, we have plus an cosine nx times bm sine of mx. And then, of course, we continue, and then this times that right here, we add bn sine of nx times am cosine mx. And lastly, of course, we do this times that, we add bn times sine of nx, and this is bm sine of mx, like this, right? So we can actually do that with the double summation now, right here. And then, remember we have this integral all the way in the front, isn't it? So be sure you still have the integral right here. So the integral from negative pi to pi. And of course, that's also colored the dx in red. What we'll do is, of course, put inside. Integrating from negative pi to pi. And then right here, I have the dx here. And then I will close that for you guys. So I did put down the dx, but you guys might not be able to see. So let me just... Okay, so this is... How's that? No? Okay, so I did have the dx and I do have the parentheses. Just in case if somebody could not see it, I just want you guys to make sure you have the dx and that. All right? Cool. Now, this is rather bizarre because we have 1, 2, 3, 4 things in this integral, but it's actually not that bad at all. Again, an, am, and all the coefficients, just don't worry about that. Pay attention to the sine cosine functions, and I will write down some notes right here for you guys. First thing first, right? Note. Let's look at the integral from negative pi to pi. Let's look at this one first. Cosine of mx times cosine of nx times cosine of mx. And if you guys have seen my video on getting the formulas for a0, an, bn, yeah, it's pretty much that part right here again. Let me tell you guys this right here. When we have this integral, we only have two possible outcomes. It's either we get 0 or we get pi. This will be 0 if n is not equal to m. And this will be pi if n is equal to m. So this is very nice because when we have the summation in blue, when m goes from 1 to infinity, we actually just have to consider one term, namely when m is equal to n. Put it here. So we actually just have to deal with one summation. You'll see, because the other ones will be 0 anyway, thanks to this right here. And then I will put down the other one for you guys as well. So the other one is when we have integral from negative pi to pi. As you can see here, we have cosine times sine, right? So I'll put this down right here for you guys. So when we have cosine of nx times sine of mx dx, guess what? This right here is always going to be 0 because cosine is even, sine is odd. Even times odd is odd. So all in all, here we have an odd function. Integrating this over negative pi to pi, we get 0. Very nice. So this is true for all n and m. Very nice. And of course, this situation, sine, cosine, it's right here as well. Don't let the n or m bother you, so I don't need to write that down again. The last situation is when we have sine and sine, right? So integrating from negative pi to pi, we have sine of nx times sine of mx dx. And again, for this integral here, we have two possible outcomes. It's pretty much the same as this one. So I'll put down 0 or pi. This right here is 0 if n is not equal to m. This is pi if n is equal to m. So that's the idea. So real quick, based on this right here, especially the middle one, we know this and that will be just 0 when we integrate from negative pi to pi. So that's nice. Well, the only thing that we have to consider, the blue part, is when m is equal to n, because that's the only part we will actually have some values for this integral, right? So let me just put this down right here for you guys. All we want is, I will just put this down here. All we need is when m is equal to n, like that, right? Let me see. When m is equal to n. So here is the idea. M goes from 1 to infinity, so that means 1, 2, 3, 4, 5. So and at some point you are going to hit n. Put the n here. Right? The other case you don't have to worry because when you integrate the other case, it will be 0 anyway. So you just have to consider that part. Let me write that down right here for you guys, which is an in blue and then cosine of nx, just that part. And then don't forget we still have the summation in black, which we have to multiply this part with the an and also the cosine nx in black. So I'll put that down, an cosine nx right here. And again, don't forget we have the summation when n goes from 1 to infinity. And don't forget we have to look at the integral as well. So consider this part and then the integral from negative pi to pi dx. And now here's the beauty. If you look at the red part, which is the cosine nx and also the cosine nx, again, m and n are the same right here. The red part right here, thanks to this, we have just pi. So this is what we're going to get. Pi is just a constant multiple, so I will just put that all the way in the front of the summation. So we have pi, and we have this sum as n goes from 1 to infinity. And then don't forget we have an times an inside, which is just an squared. That's so wonderful. So I'll just put this down right here, an squared. Cool. Now we do the same for this one, right? For this integral, the sine situation. And when we have that, don't forget we still have this summation plus the next summation. I'll just write this down right here though. Again, this will be n equals 1 to infinity. It's the same idea. When m is equal to n, you put the n into the m's right here, and then you have all this part, which is bn sine nx, and then sine of nx, also the bn, but this in blue. So this is what we have right here. And don't forget integral, right? Everybody's favorite. Negative infinity to positive infinity. I mean negative pi to positive pi. And then we have the dx here, and you know the deal. This and that, the red part will give us pi, so let's put down the pi first. Okay, so this is equal to pi, and then we have the sum as n goes from 1 to infinity, bn, which is just bn squared. Very nice. Alright, so the third part, finally we this right here. This right here is nicely equal to this plus that. Of course, we can put the things together inside of just one summation, right? So hopefully that's clear. And now let me tell you guys what Parseval did, right? As you can see, when we integrate f of x to the second power, going from negative pi to pi, we have this. It's equal to this. That's 0, right? So just this plus these right here, right? And notice everybody has pi, so we'll just divide pi for everybody. So let me write down the statement for you guys. Let me just write this down for you guys here. Okay. Let me put this down. Integral from negative pi to pi. Again, we will be, putting the f of x in the parentheses and square that dx, right? Well, this is equal to this part, but I want to put the pi by dividing the pi on both sides. So I will have the 1 over pi right here. That's just a tradition. People do that. Okay, so I didn't do it. Other people did, just follow. So I will just put down 2 times a0 squared like this. And then, of course, this pi right here already, okay? So we just have these two things that we'll put it in one summation. So we add the sum as n goes from 1 to infinity, parentheses, right? an squared and then bn squared. And that is very, very nice. Let me just write this down nicely for you guys, like this. This is the Parseval's theorem. Very nice. And this is what I use when I take f of x to be x squared, and I figure out the coefficients for a0, an, and bn, and put it here, and I get a really nice sum. The sum as n goes from 1 to infinity of 1 over n to the 4th power. You can also do this with and to figure out the sum of 1 over n squared, 1 over n to the 6th power, and all that. But I will leave that to you guys, right? Well, question for you guys. Is it possible for us to use this right here and also the Fourier series to figure out the sum as n goes from 1 to infinity of 1 over n cubed. Is this possible based on the things that I have demonstrated for you guys? Well, leave a comment down below, let me know. But anyway, hopefully you guys all like this video. If you do, please give me a like. Thank you guys so much. And as always, that's it.